This is Chaya Chandrakar from Sri Venkateshwara College of Engineering. Today we're going to study about determination of pH using glass electrode. Introduction to pH. What is pH and pH scale? pH is the abbreviation of potential of hydrogen and is a measure of concentration of hydrogen ions in a substance. pH scale is logarithmic, meaning each number represents a 10-fold change in acidic and basic. Importance: pH can control the availability of nutrients, biological functions, microbial activity, and the behavior of chemicals. pH can predict what kind of chemicals can be released from a sediment into the water column. We can rate a pH scale as 0 to 6 can be concluded as acidic, and 7 will be neutral, and 8 to 14 is alkaline, which will be basic in nature. What is glass electrode? A glass electrode is an electrochemical sensor used to measure pH. It works based on potential difference generated due to interaction of H plus ions with the glass membrane, commonly displayed with a reference electrode, for example, EAG and AgCl electrode. Principles of glass electrode. The potential difference is generated across the glass membrane due to H plus ions, and this follows Nernst equation, which will be E is equals to E naught plus 2.303 and RT by NF log of H plus, where E can be measured potential, E naught is the standard electrode potential, R is universal gas constant, T is temperature in Kelvin, and N is the charge of ion, and H plus ion charge will be always equal to 1, and F is the Faraday's constant. The potential of glass electrode EG has three components: the boundary potential, the potential of the internal AG and AgCl reference electrode, a small asymmetric potential. EG is equals to potential of boundary and the potential of the reference electrode and the small asymmetric potential. So this can be concluded as constant minus 0.0591 pH plus potential of the reference electrode plus the potential of the asymmetry. So EG is equals to E naught G minus 0.0591 pH, where E naught G is a combination of three constant terms, which can be E naught G is equals to constant plus the potential of the reference electrode plus the potential of the small asymmetry. Determination of pH using the glass electrode. When a thin glass membrane is placed between two solutions of different pH values, potential arises between the membrane or across the membrane. The potential difference varies as the pH of the solution varies. In practice, pH of one solution is kept constant, and the other electrode depends on the potential of the other electrode depends on the other solution. So this the other solution will be always the experimental solution, which pH is to be known. So the procedure to know the pH value will be: the glass electrode will be immersed in the solution whose pH is to be determined, and the cell representation for this will be calomel electrode dipped in KCl with solution of unknown pH in glass electrode. It is combined with a reference electrode such as calomel electrode through a salt bridge. The cell assembly is represented as below in the diagram: a calomel electrode with KCl inside and a glass electrode dipped in an unknown solution of pH whose unknown pH is to be known, and these two will be connected with the pH meter. EMF of the above cell. E cell is measured using an electronic voltmeter with a pH meter. The EMF of the cell is given by E cell is equals to E cathode minus E anode. That will be the first equation. And E cell is equals to E glass, which will be the potential of that glass, minus ESCE will be the second equation. So E cell is equals to E naught G minus 0.0591 pH minus ESCE. So E cell minus E naught G plus ESC is equals to minus 0.0591 pH. So if we take minus 0.0591 pH to the left hand side, it becomes 0.0591 pH will be equal to E naught G minus E cell minus ESCE. So our pH will become E naught G minus E cell minus ESE divided by 0.0591. So the E naught G value is evaluated by dipping the glass electrode in the solution of known pH and measuring the EMF of the cell formed when the combined with its calomel electrode. The applications of this experiment will be environment monitoring, which will be used for environment monitoring of pollution and solid soil acidic. Food and cosmetic analyze, used to analyze food and cosmetics. Industrial process control, it will be used for controlling the processes which will be used in industries. Research labs will be used for the research purposes in the labs. Blood pH measurement will be used for blood pH and modern APG analysis. And water quality will be used for measuring the water quality for municipal water supplies and swimming pools. Healthcare and clinical applications will be used in healthcare, such as blood chemistry. The advantages of this experiment is chemical inertness. The glass electrodes are often used when chemically inertness is essential, and the glass electrodes are very sensitive, and it is easy to use and easy to clean and calibrate with standard buffer solution. Glass electrodes can cover a wide range of pH from acidic to alkaline, which will be basic. Glass electrodes have a rapid potential response and they are very low cost, and it is non-destructive, which does not cause any harm while performing the experiment. The glass electrodes can be applied to a wide concentration range. Limitations of this experiment will be fragile and can break easily, requires regular calibration, can't measure very basic solution which will be less than 12. Alkali error at high pH values. We can conclude this experiment by pH electrodes rely on combination of electrochemical reaction and an ion selective salt bridge to produce a measurable voltage potential between the solutions. And the conclusion of determining pH using glass electrode is that pH of a sample can be calculated by measuring the electromotive force generated at the electrode membranes. Thank you.